Hello everybody, going to do Advent of Code Day 2. It is currently 6:49 AM. I woke up about like 30 hours ago, didn't sleep last night. You arrive at Easter Bunny headquarters under the cover of darkness. However, you left in such a rush that you forgot to use the bathroom. Fancy office buildings like this usually have keypad locks on their bathrooms, so you search the front desk for the code. In order to improve security, the document you find says bathroom codes will no longer be written down. Instead, please memorize and follow the procedure below to access the bathrooms. The document goes on to explain that each button to be pressed can be found by starting on the previous button and moving to adjacent buttons. On the keypad, U moves up, D moves down, L moves left, and R moves right. Each line of instructions corresponds to one button, starting at the previous button, or for the first line, the 5 button. Press whatever button you're on at the end of each line. If a move doesn't lead to a button, ignore it. You can't hold it much longer, so you decide to figure out the code as you walk to the bathroom. You get your keypad like this, post instructions are, and then a bunch of examples. So let's start by just bringing in our puzzle input. Okay, how many lines long is it? It is... My font is... This font is too large. I'm going to have to turn it down. Sorry, guys. Hopefully it's still readable to you. 1, 2, 3, 4, 5, 6. Well, it says like 5 lines long. It's not too bad. Okay. I'll close it for now. Const puzzle of type aesthetic str equals include str puzzle.txt. Okay, that gives us our thing. How's this best coded? This is essentially a finite state machine with transitions, which Rust is incredibly elegant for, so let's just code it like that. We'll call it enum keys. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are all our keys. Derive, debug, copy, clone, eck, partial eck. Shouldn't need anything more than that. Implement keys. Okay, and so now we do transitioning. So we say we're going to have an up transition, which takes in an instance of self. Technically this is going to move it, but it's copy safe, so it doesn't really matter. And it's going to return a new keys value. So then we're going to just match on self. Okay, so looking at the diagram, where do they all move? One moves up to 1. In fact, you know what? We can do this more elegantly. So what can move up? 4 can move up to 1. 5 can move up to 2. 6 can move up to 3. And in fact, yeah, you know what? We're going to say use everything in keys. So we can just say... That might be in the wrong place, but like I can just move it if need be. 6 can move up to 3. 7 can move to 4. 8 can move to 5, and 9 can move till 6. Okay, this should not build right now because I need to add the edge case, and the edge case is anything not listed here moves to itself. Say other moves to other. So these are all of the ones for which it should just be ignored. We're just going to stick this up here. Cannot find puzzle.txt. It's because I called it puzzle. Why did I do that? Let's fix that. Rename to puzzle.txt. Alright. Yeah, builds, complains that I'm not using anything. It runs and it does nothing. Wonderful. So now we just need to do like 4 more of these, so down match on self, we will say 1 goes to 4, 2 goes to 5, 3 goes to 6, 4 goes to 7, 5 goes to 8, and 6 goes to 9. There, by the way, I'm aware there are way more elegant ways to do this just with numeric solutions, but I'm explicitly coding this to demonstrate, you know, how nice Rust is for finite state machines. So if we go left on the keys, then we have, I'm just going to pull up the diagram on the monitor so I can visualize it easier. 2 goes to 1, 3 goes to 2, 4 goes, why every time I type that symbol, do you know what, set no bell, set no bell, how do I turn bell off? No? Set visual bell. No visual bell. Wonderful. 4 goes to nothing. 5 goes to 4. 6 goes to 5. Alright, I have an audio bell now, which is annoying, but whatever. It's going to be more pleasant for you guys. I wonder why less than triggers my bell. It's an interesting bug. That's going to really annoy me. Where's them? Them? Are you coming through here? No. Must be a system sound. Yeah, system sound. Alright. 9 goes to 8. So hold on. 2 goes to 1. 3 goes to 2. 5 goes to 4. 6 goes to 5. I should have 8 goes to 7. That's what I'm missing. 8 goes to 7. And then other goes to other. Let's say don't do anything. And finally, right. We say again match on self. Okay, 1 goes to 2, 2 goes to 3, 4 goes to 5, 5 goes to 6, 7 goes to 8, and 8 goes to 9, and other goes to other. Wonderful. That's all of that code written. Right, let's write our parsing thing now. So 4, in fact, let's give ourselves a state. Let new state equal 5, because we're supposed to start on 5. Okay. Let's go puzzle. 4, that, you know what, I'm going to say puzzle.lines. It's going to get every line, I think. There's a method that exists. Let's check that. It's an anstra. or whatever. If it's on lines, it'll be on str. They're the same thing. Yeah. So we're going to take all the lines, we're going to do some mapping. So for every line, we're going to take all the cars. But we're going to say let mute state equals 5 inside here. But that's my alarm telling me that it's 7 and I need to get up. Sorry if you heard that. How long have I been going? 10 minutes, wonderful. Let's see if we can make this shorter than the last one. So our status starts at 5. I kind of want to just do like print line this with like a collect into a vector of whatever I spit this out as at the end. That seems like a reasonable way to code that. Okay, so we do for every single character in the line. Just say a for token in all our characters. Match token. Okay, what do we have? We've got, where even is it? It's here. No, they are just like D-U-L-R caps. Yeah, so U means we say state equals state dot up. D means state equals state dot down. L means state equals state dot left. R means state is state dot right. And anything else should panic because it doesn't exist. It should be there. Like spell. Okay. That's like our whole code, maybe. We need to dump the state, so I guess we'll just do like state. Okay, that'll be fine. Puzzle is unknown because it should be in caps. Alright, that was fun. 98575. 98575. Submit. Right answer. What's part 2? We are at 12 minutes. Okay, part 2. Finally arrive at the bathroom. Several-minute walk from the lobby. Much to your blood's dismay, the keypad is not at all like you imagined it, but instead you are confronted with the result of hundreds of man-hour bathroom keypad design meetings. Still start at 5 when you're at an edge, but the outcomes are very different. Alright, time to recode our entire transition diagram. Okay, so for this, I am going to do, all we need to do is include an A B, a C, and a D. And I'm going to cheese it a little bit, in that we're going to delete this, and we're going to delete this, and we're going to delete this, and we're going to delete this. Okay, so all of these, you guys just like come in here and then align yourselves nicely. Right, 1 goes up to 1, 2 goes up to 2. In fact, we'll just delete these lines. 3 goes up to 1. If you want to see what I'm coding based on, it's just this. Like that diagram, it's just on my other monitor. 4 does not go anywhere. 5 does not go anywhere. 6 goes to 2. 7 goes to 3. 8 goes to 4. 9 does not go anywhere. A goes to 6. B goes to 7. C goes to 8. And D goes to B. Other goes to other. Okay. Okay, going down. 1 goes to 3, 2 goes to 6, 3 goes to 7, 4 goes to 8, 5 goes nowhere, 6 goes to A, 7 goes to B, 8 goes to C, 9 goes nowhere, A goes nowhere, B goes to D, and C goes nowhere, and D goes nowhere. Other goes to other. Okay. You know, can we like just register this? Like 8 yank inside this shit. Okay. Oh god, what am I doing? Paste from 8. And then align yourselves. Okay, moving left. 1 goes nowhere, 2 goes nowhere. 3 goes to 2. 4 goes to 3. 5 goes nowhere. 6 goes to 5. 7 goes to 6. 8 goes to 7. 9 goes to 8. A goes nowhere. B goes to A. C goes to B. D goes nowhere. Other goes to other. Last batch for rightward movements. 1 goes nowhere. 2 goes to 3. 3 goes to 4. 4 goes nowhere. 5 goes to 6. 6 goes to 7. 7 goes to 8. 8 goes to 9. 9 goes nowhere. A goes to B. B goes to C. C goes nowhere. D goes nowhere. Other goes to other. Run the code. CD8D4. So glad that's right, because if I did the data entry wrong, that was going to be painful. 17 minutes long, shorter than the previous one. Oh, that's nice. Bye.